I'll wait for it to start recording. There we go. So we're going to do 3 more exponent rules, okay? But they're a little bit different. These are actually a little bit easier. So this lesson should only take about 20 minutes or so, 20 minutes, half hour to get through. One thing I want to remind everybody of, and because I can even look up here, make sure you do, so if I use Farley here, for example, make sure you do your checks, your Wednesday homework check, and there's a Thursday homework check, okay? I can see who's done it already. I can hide the names here, right? But only this many people have done this so far, okay? The homework check. And I can see how well you do it, because if you just click through everything, it shows up as like an X. So like, for example, this person here wrote stuff in, right, explained why, right? Where this person here, they did explain why. I wonder if that showed up wrong. I'll have to check that one, okay? But just don't click through everything, but go do those checks, okay? For me, so I know how well you're understanding things.
What do you mean
as
by
a group?
I tried doing yesterday's check this morning, but it wouldn't let me click on it.
Like, it wouldn't let you click on it?
Yeah.
Okay, I'll go back into those settings and see if there's something.
I just sent it in the chat.
Okay.
Done it either for today.
No, it's in your homework file.
Oh.
So if you go to your homework, there's a like Wednesday work, Wednesday solutions, Wednesday hand-in, Wednesday check. Just like today, Thursday work, Thursday solution, Thursday hand-in, Thursday check. I will go back, Dominic, and see. I have you down here, Dominic.
What do you mean?
You've done it. You worked it through yesterday, didn't you?
I did, yeah, but it wouldn't let me send it in.
Oh no, it automatically goes to me.
Oh, it does. Oh, okay.
Yeah, like I have your name here with all the things that you've done.
Awesome. Okay.
I'll double check and see if that may be why you couldn't get in. But
Yeah.
if you go today, there's another one there too.
Oh,
Okay.
probably. Okay, thanks.
So let's make sure do that check. Okay, that allows me to see how well you're doing, or if there's a concept that I think people are getting that they aren't getting. Okay. Oops. One note. Boom. Good. Okay. So one thing I forgot to go over was fractions with exponents. But if you think about it as a power rule, right? There's a 1 here and a 1 there. So for power of power, it would be 2. Oops. 2 to the power of 2 over 3 to the power of 2. Because this would multiply there and multiply there, which would equal 4 over 9. Does that make sense, everyone? Let's just do another fraction. So if I did like 6 over 7 to the power of 3, okay, that would equal 6 to the power of 3 and 7 to the power of 3. Actually, let's change that. Let's do a big one. So if we did like 2 over 3 to the power of 8. Now, some of you are like, how do I do to the power? If you have your calculator here, and I'll look up the website for this today. You go 2, and then there's a button like this, which is like a Y with an X above it, or something like that. And then you can type in your exponent, whatever you want your exponent to be. Okay? So that's how you kind of do those big exponents that are above 2. It may look like this, the button. If I want to go 2 to the power of 8, that'd be 2/8 over 3/8. If I want to go 2 to the power of 8 on my calculator, I go 2 And there's going to be a button that looks like this, or it may look like this, or I've seen some that look like maybe X and there's a box up here, or something along those lines. Okay, so there's a whole bunch of different options depending on your calculator make. Okay, do we understand how to work fractions in there? Like how a fraction, like fraction to the exponent of something works? Am I gonna let Farley talk for everyone with the yup? All right. So I have one. Throat's dry. So I want everyone to get out a calculator for me. Okay. Where's my pen gone? We're going to work with a 0 exponent. Okay. Spare a rule up here. I want you to do these 4 calculations for me. 4 to the power of 0, 100 to the power of 0, 264 to the power of 0, and 1 million to the power of 0. Okay? I want you to figure out what that equals.
Don't they all just equal 1, basically?
Did you try it?
Yeah.
Did anyone else get the same answer? Where's my iPhone emulator?
The 1 million one, that equals million.
No, it won't.
That's
Do
what
it over again.
That's what oh no, it says 0, not 1. Yeah, so 1.
Good. And for the people who have an iPhone that refuse to get a calculator because you're crazy, this is how I type it in on my calculator. If I want to go like 4 to the power of would look to be the y to the x here, and then press 0 and equals. Okay?
So Mr. O, can I just hand in the homework? I didn't realize they were even a thing. I just wasn't paying attention. Can I just do both of them tonight when I get home from work?
Yeah. Go ahead. Okay? So any number to the power of 0 equals 1. No matter what you do, anything to the power of 0 equals 1. Okay? So that's 1, that's 1, that's 1, that's 1. If I had this, let's do, what would x to the power 0 equal? Can anyone make a guess for me?
0.
Make another guess? 1. Because x is just a number, right? So no matter what number I put in there, anything
0.
to the power 0 equals 1, right?
Oh,
I could even write this. What's that going to equal? That whole thing is to the power of 0. So anything to the power of 0 equals 1. Okay? Does that make sense to everyone? It's kind of weird in a way, but it works. So here's your rule to the power of 0. So whenever you see anything to the power of 0, like this could be a super long question. I could give you like a question that would take you 10 minutes to do. That looks like a long question, right? But can anyone tell me what the answer is? Because this is up here.
1.
That'd be 1. Yep. Because no matter what number is in there, it's to the power of 0, which is going to equal 1. All right. So when you go to make your note, if you go to your notes itself, you can see here it says 0 exponent, right? That's where you put that. Okay. Now for the interesting one. Negative exponent. Okay. So here, let's take a look at this. I'm gonna write that up there to start. All right. How should I lead you upon this path here? Can anyone put that in your calculator and tell me what it equals? So 2 to the power of negative 2. What does that equal?
I don't know if this is right, but my calculator gave me 0.25.
Okay. 0.25.
Yeah, me too.
Okay. What's another way to say 0.25?
1/4, like 1/4.
1 over 4. Good. Good. What is... Where's my calculator? Ooh. What is 10 to the power of negative 2 equal to?
0.01.
Do you know what that is as a fraction?
1/100th, or yeah.
1/100. Good. Okay. Can anyone see a connection between these two? Let's go. We're working through them right now, Abigail. Okay, Jackson. Double check the notes when you get home. Okay, this is the last concept we're doing. Okay, so does anyone see a connection between the first line here and this line here? That should be a negative there.
Oh, yeah. If you times it by itself, it equals the bottom of the fraction. Like 2 times 2 is 4, 10 times 10 is 100, and then 4 times 4 is 16, and so on.
Good. The denominator is, yeah. Good. Olivia said it there as well. The denominator, so I'm going to erase my green here. The denominator here is the same as this squared. So would you guys agree with me that this is true? Those are all equal? And this would be equal as well. 1 over 10 squared, 1 over 4 squared, and 1 over 3 squared. Do you guys agree with me that those are equal? Yes, no, maybe so? You don't think so? Let's try it in our calculator. So 1 over 10 squared. So that's the same as saying 1 divided by 10 squared. That equals 1 over 100, right? 1 divided by 4 squared is 1 over 16. I could flip it and make it look like a decimal place as well. It's okay to be confused right now. I want you to be confused, Andreas. Okay? I haven't came out and told you the rule because I want you to kind of see the rule. So the rule with exponents that are negative is how you make a negative exponent positive is you flip it. So if you remember, all these numbers, like all these numbers are over 1, over 1, over 1. We just never write it. Okay? But to make a negative exponent positive, you flip it to the bottom. And that's why it's kind of demonstrating here. It was 2 to the negative 2 equals this, which equals this. But also, if I move that to the bottom, like 2 to the negative 2, and I moved it to the bottom because 1 over 2 squared, and 2 times 2 is 4. Okay? So the rule, if I were to go up here to my rule section, x to the negative 1 is the same as saying 1 over x to the 1. Okay? Just as this one here is, if I have a negative there, I can flip it, and if I take it to the top, it becomes positive. And if you work this way, to make a negative exponent positive, the denominator and the denominator and denominator switch places. Okay? Does that rule make sense to you, or is that kind of confusing? So let's ask you some questions. It's more clear now. Yeah, I made it unclear on purpose because I want you to think about it instead of just giving you it. So can you make this a positive exponent? So if I wanted to make this one a positive exponent, If it's a negative exponent, what I do is I flip it. So this would become 1 over 9 to the 4 is the positive exponent of that number. These two numbers are equal, right? And we remember there's like an imaginary 1 down here that we just never write. So if I want to make this one positive, I flip it. And it become 1 over 10 to the 3. Now, what would this be as a positive exponent? Can you guys write in chat what that would be? Can you guys write in chat what do you think that would be as a positive exponent?
Wouldn't it just be flipped? Like
Correct.
5 at the top and 1 at the bottom. 5 would be positive.
Say it again for me.
Wouldn't the 4 just be at the top and the 1 would be
Okay.
at the bottom and the 5
Good.
would automatically be positive?
Yep, good. It would look
Yeah.
like that. Perfect. So whenever you have a negative exponent, you flip your fraction, for lack of a better term, right? Knowing that like this still has a fraction underneath it. You flip it. Right? If I had this one, what would be the positive exponents for that one? Could someone tell me? Is everyone going to a food coma after lunch?
Would it be the y on top to the power of 2 and x on the bottom to the power of 3?
Perfect. Good job.
So do you basically just swap them and then positive it?
Yep.
Oh, okay.
Now I'm gonna of course you guys now get it, so I'm gonna mess with you some more.
Nah.
What would I do to make that a positive exponent? Tell me what would happen to the inside.
Wouldn't the inside become negative?
No? Think about what we've been doing. We've been
The 2 and the 3 would flip.
good. We'd switch spots. Now you could think about it like this. This is the exact same question I kind of just gave you, right? Like if I brought those in, that's what it would look like. Then in order to make it a positive, I'd flip it. Oops. That would be 3 squared over 2 squared. Okay. Does that make sense to you? I'm going to give you a question now, and I want you to answer this question as a positive exponent. Do you want me to walk you through the first one? Or do you guys think you have it? Pardon, Dominic?
Can you walk through the first one?
Yeah, no problem. So we have division here. So when we divide, we subtract. So 10 minus 12 is going to be x to the negative 2. And y is going to be 3 minus 5, which is going to be y to the negative 2. Then I want positive exponents, so I'm going to flip them. So I take it to the bottom, and they'd be positive. Did that make sense, Dominic?
Yeah, I get it now.
Okay, let's
Can
do
you
another
just
one.
can you just stay there for a sec?
Yeah, I'll leave it like such. Let's do this one. I'll give you about 30 seconds to work ahead if you wish. If you want to wait for me to do it, that's fine as well. Generally, you always want your answers to be in positive exponents. All right, who wants to walk me through this one? Do I have any volunteers?
I mean, I'll try, but I don't really
Alright.
know what's right. So you add the x's, so that'd be x12 and y8, and then x20, and then so you divide x12 by x20, which I believe that'd be 0.6, right?
No, remember it's minusing, right?
Oh, sorry. So then that would be 12 minus 20. What would that be? -8?
Yep,
And then 8 minus 10, which is -2.
good.
And then, so you flip them. So it would be 1 over x8 and then y2.
All right. I'll give you one more question here. I'll make it easy but hard. Now remember, I want each of my exponents to be positive. Okay? So the hint here is they don't have to stay together. The x and y don't have to be beside each other in the end.
Would you subtract 5 from 10 for that?
No, 10 minus 5. So it'll be 10
Yeah,
minus
10 minus
5
5.
and 5 minus 12. So what's that going to give me? That's going to give me x to the 5, y to the -7. Now, are both my exponents positive? Yes or no?
No,
Which one is positive?
the 5.
Or the one with the x, right? Yeah.
Yeah.
So let's just leave it there. Now, what happens to the y?
Goes to the bottom.
Yep. And here's your answer.
Oh, okay.
Does that make sense to everyone? Let me look at your homework to make sure. Now for this one here, Abigail's going to get lucky here since I always pull hers up. For this question here, it says express each fraction or decimal as a power with a negative exponent. Okay. So let's do this one here. So it wants us to, it's 1 over 49 is the question, right? What does 49, what to the power of what equals 49? This is where you might have to do some calculation stuff, but you're going to have to like find what multiplies itself to equal these numbers. What to the power of what? I'll give you a hint. 7 to the power of 2 equals 49, right? Now it says, spreadsheet fraction goes on as a power with a negative exponent. We have a positive exponent here. How do I make that negative? Can someone help me out?
Just put a -2, then flip it.
Good. I flip it and give it a -2. Perfect. These ones are good. Remember, with fractions, you just flip them. Good. So I would say, let's take out 4. For this one, these are pretty much the same. So I'll type in chat what questions I want you to do. So 1, 3, 5, So 1, 3, 5, 7, 8, and 9 and 10 will be bonus. Okay. Before you log off, I want you to do this last attendance check. Okay, and as with before, I'll be online for a bit. So if you have questions, if you want to keep working on your work, you can stay online, and I'm going to stay and do work. Yo-san, can you check your email for me? Please and thank you. Besides that, do your attendance check on the way out. If you're heading out, if you're not heading out, you can continue working away. By a rating of 5, how did today go? Like 1 through 5. Okay. Okay. Gabe, are you still there?
Yeah, sorry, I'm here.
Okay.
What's up?
I'm just looking at your responses.
Yeah, no, I'm
to-
so confused.
Are you okay?
I'm just gonna watch a bunch of the videos that you put on it for tonight, and then I'll just do it on my own. I'll be fine.
Okay. Worry more about the exponent stuff.
Yeah, the exponent stuff, I'm definitely more confident with, like, because I've just
Okay.
done it. I've done it before. Like, it'll come back. You know what I mean?
Yeah. The domain and range will come. I'll keep drilling that in you through like that'll be a whole semester thing. I don't
Okay.
expect everyone to have it down right now. Like if right
Yeah,
now
no,
you can look. Go ahead.
No, that's okay. It's okay.
No, if right now you can look at a